I'm going to describe the mechanics of what's going to happen now. The International Space Station is getting closer and closer and closer to the South Florida Science Museum. Here at the Science Museum, the amateur radio group has put together 2 radio stations, a primary and a backup, with 2 redundant antenna systems above this building. One of them is a high-gain antenna system that is pointed over the horizon in the direction from which the International Space Station is going to be approaching the Science Museum. I don't know if you can bring it up on the screen or not, but there's a map projection on the computer screen, and it has a round circle which represents where the International Space Station is, and from the space station, how much of the Earth you can actually see looking out the window of the space station. That's called line of sight. You can see everything below you and to the horizon as it appears to those aboard the International Space Station. That's actually the communications footprint. So as that footprint moves closer and closer to South Florida, we will eventually be able to access them by talking to them via a VHF radio. And Mike McIntosh is manning the 2 radios in the room today, and he will be making the initial call to the International Space Station. He'll start calling about a minute before. And as he's calling, he'll pause, he'll listen, he'll turn it over, he'll listen. When he starts hearing them call, and once we've established excellent communications, then the students will be able to start asking their questions. And as it has already been explained, we'll cue the students so that one is ready to ask a question, one is ready to take the position of asking the question. Once they've asked their question, they will remain on the platform and listen to the astronauts' response. And so that's the mechanics of how it works. Now we're at T-minus what, about 4 minutes? International Space Station, and hear them almost at the horizon because of the gain of his antenna system and the sophistication of his radio. So I think at this time what we should do is turn it over to Mike and let him start calling the International Space Station. And as he does, you'll hear him call, pause, you'll hear him call and then pause. And then eventually, this sound that you hear in the background, that static, that noise, it's going to disappear, and you'll start hearing the voice of the astronaut aboard the International Space Station responding to Mike.
This is Whiskey Sierra 4, Foxtrot Sierra Mike, over.
Do you hear that static? That static has been described as the background noise
NA1SS. This
from
is
the
Whiskey
Big
Sierra
Bang.
4, Foxtrot
When you
Sierra
open the
Mike,
squelch
over.
up on that radio and listen, that sizzling sound is the cosmic sound of the original Big Bang of the universe, still available to be listened to, heard on a radio system.
NA1SS, NA1SS. This is Whiskey Sierra 4, Foxtrot Sierra Mike, over. We're at 46 seconds.
If you look at the computer screen, you can now see
NA1SS, NA1SS. This is Whiskey Sierra 4, Foxtrot Sierra Mike, over.
the communications footprint is now just touching the little building that represents the South Florida Science Museum.
NA1SS, NA1SS. This is Whiskey Sierra 4, Foxtrot Sierra Mike, over. 10 seconds to acquisition. NA1SS, NA1SS. This is Whiskey Sierra 4, Foxtrot Sierra Mike, over. We should have them. NA1SS, NA1SS. This is Whiskey Sierra 4, Foxtrot Sierra Mike, over.
WS4FSM, this is NA1SS. How do you read? Over.
This is Whiskey Sierra 4, Foxtrot Sierra Mike. Ready for your first question, over?
We are ready for your first question. Over.
Is NASA planning an experiment on how to produce water in space? Over.
That's a good question, and actually we are producing or reproducing water already in space. We go to the bathroom and we pee, and then that pee and station in the air gets collected, and then we recycle those and drink those. Over.
Can you describe the integrated cardiovascular experiment you have been performing on this mission? Over.
Wow, that's a very special question. So we have this experiment called the integrated cardiovascular, and we hook up like a heart rate monitor and blood pressure monitor equipment on us, and we collect data for 24 to 48 hours, and you do this maybe every other month or every month, and we collect data and see how our body adjusts to microgravity environment. And a lot of people are doing it, so hopefully all those data will be very useful for the scientists on the ground. Over.
In space, the human body is put through so much stress. How did you prepare physically and mentally for this?
Well, I think the biggest way to prepare is training. And before we come up here, we go through training for maybe at least 4 years, and longest would be like 10 years. You go through the astronaut candidate training, and then after a while you get assigned to a mission, and then for that particular mission. So you know your systems inside out, you know what to do in an emergency, so you have enough time to think. Feel less stressful when those situations occur. Over.
How has your perspective on Earth or on space's size and expanses changed since leaving Earth? Over.
That's a good question. On the ground, we have mock-ups where we can simulate or train physically moving things around or operating systems. Now, when we do that, we are still walking on the floor. However, up here, we can float over someone and pass by someone in mid-air, use the ceiling, use the wall, whatever. So, on the ground, you kind of feel two-dimensional, and then on orbit, you can easily move three-dimensionally. That makes space a lot bigger, and it seems a lot bigger when you come up here. Over.
What future space discovery are you most excited about? Over.
Well, I think we can go even further out. That might be a great discovery in space. And also, there's a lot of things that we don't know about our own human body and Earth. So by looking things in microgravity or looking discoveries, which is very, very exciting. Over.
How is waste disposal currently handled on the space station? And what is your opinion on how waste is disposed? Over.
Well, waste right now, we, apart from water, which I talked about already, water is collected and then recycled and reused, but there's a lot of garbage that needs to be trashed. For instance, we eat and then we have packagings, we use equipment, maybe that failed, and then you have to swap it out with a new one. So you do accumulate a lot of trash items. Now, what we do with those trash items, we collect it and then wait for a unmanned vehicle that needs to depart and head back home, and we load those vehicles with all these trash. Once they enter the Earth's atmosphere, they will burn up. So that's how we get rid of those. Over.
What was the most interesting experiment you have done in space? Over.
Well, there's a lot of interesting experiments going on right now at this moment. Two of my favorites, maybe. One is deploying a very small satellite, about 4 to 5 inches size in diameter, and we launched it using a robotic arm and with the help of a spring force. It just opened the door and then it launched and it went out to space. The other experiment is using a very, very small fish called the medaka. And we have them in the aquarium, and we see if microgravity has any effect on their bone and muscle. And then by that data, we kind of know what happens to the human being's body too. Over.
What is the most beautiful or inspiring thing you have seen from space? Over.
That is a tough question because everything looks beautiful from space. My favorite, though, might be the clouds because you can see different shapes of clouds, and depending on the time of the day, you can even see the shadow of those clouds, and it would be very, very long. So my favorite would be the clouds. Over.
When you look back on your life, what event or activity had the largest impact on your desire to become an astronaut? Over.
Well, first of all, as a child, I was watching a lot of science fiction movies and cartoons. Star Wars, Star Trek were my favorite. And then I also had an opportunity to go to NASA's Kennedy Space Center and see the rockets. So by looking at these, I had my dream of going to space. At that time, I didn't really know about astronauts, but that's how I started dreaming of going to space. Over.
Can you see coral reefs from space, and if so, which ones?
Over.
We see a lot of coral reefs. We don't see the details, but from up here with a big lens, we can see the beautiful details. It's a little hard to see, but a lot of coral reefs around the Earth, like over at Australia or in the Pacific, those we can definitely see from space. Over.
What are the benefits of doing experimentation in microgravity? Over.
I'm sorry, could you repeat the question, please? Over.
Say again.
What are the benefits of doing experimentation in microgravity? Over.
Microgravity, that doesn't happen. So if you have something that is very dense and something that is not that dense, those things will melt together. So you can create new materials by melting materials and then trying to solidify it in microgravity. That kind of thing you can't do on the ground. And also you can look at
Yes, yes.
I'd like to thank a couple of our board members who are here today, Harvey Oyer and Francis Fisher. Thank you both for being here. I'd like to thank again Superintendent Gent and Jenny Pryor-Brown. This partnership that we have with the school district is...
What an incredible experience to hear from someone gazing down on planet Earth from a vantage point some 260 miles above us. Now, we want to add our kudos to the students for those well thought out questions. The questions were really interesting, and the answers certainly were much more interesting. It added up to a truly memorable, fascinating experience, a fascinating science lesson for all of us. For the Education Network, I'm Alan Gerstel.